morning students. Welcome to lecture number 22, Introduction to Welding Processes. So the objective of this class is to understand the weld drawings, selection of power sources based on supply. So you will come across the terminologies like types of welding joints, welding symbols, nomenclature of weld, welding arc and polarity, selection of power sources. So basically if we see the welding joints, we can classify the welding joints as butt joints. Okay, so two plates in parallel. So this butt joint. The next one is called as the corner joints, where the weld you are going to place over here. So at 90-degree intervals you are joining. In the butt joint, this is the area where you are going to make the weld. Next one plate over the other. You can weld on this area here or on this area here or on both the areas, depends on the loading condition. That is called lap joint. Next one, it's called as T joint. It is in the shape of T. Next one, you are bending the two sheets or two plates, and over the edge you are performing the weld. That is called edge joint. So basically if we see the welding joints, we can see the joints as butt joint, corner joint, lap joint, T joint and edge joints are available. So we can see over here in this all the joints I have marked over here. You can see on the top of the two plates I am joining as one single entity, that is called edge joint. And you can see on the two plates the outer sides I am welding that to make into a shape of a T, that is called T joints. Two plates you can see in a parallel I am joining, that is called as the butt joint. One plate I keep it over the other one and I am performing the welding at both the ends, that is called as the lap joint. And you can see a 90-degree bend I am making by making the weld at the corner. So you can make an edge joint, T joint, butt joint or lap joint or corner joint by using the welding process. Now the next parameter in the welding is the weld positions. So in the last year you did the welding experiment. In the welding experiment you have welded two plates on a flat surface. That is a horizontal welding. So flat and horizontal. You can do it on a vertical wall like this. On a vertical wall you can weld. You can see one welder is welding on a vertical wall. That's called as vertical position. The next one, this welder is welding above his head. That is called overhead weld position. So the types of joint we have seen, and the weld positions we can have flat and horizontal. We can go for vertical or we can go for overhead welding positions. So there are some standards are available. If it is a flat surface like this and if you are welding on a plate, the standard term is called as 1G. So 1G, if you see 1G on any drawing, you have to understand that the weld is performed on a flat surface like this. If the welding is done on a horizontal surface like this, okay, horizontal surface like this, we call that as 2G. If you are doing it in a vertical up or down position, maybe going from here to here or from top to bottom, we call it as vertical 3G, or we call it as the position of the plate as 3G, and overhead we call it as 4G. So you will have 1G, 2G, 3G and 4G is coming. Okay, you have to understand that based on whether it is marked as G, it indicates that it is a plate welding is. That is, you can see over here in the case of pipes also, you can see you can have axis vertical, you can have axis horizontal and you can have axis incline. So based on that, again the pipe also it will be marking as vertical piping as 2G, horizontal as 5G, inclined 45 degree as 6G. So in a combined fashion, it is marked over here. There are two terminologies will be there. One is called F and next is called G. F corresponds to fillet weld and G corresponds to groove weld. That is, you can see in all the previous figures, you can see over here a groove is made and on the groove only the weld is being performed. Okay, so if it is groove is done, we call it as, we will have this letter, the English letter G will come over here. Whether it is a plate or whether it is a pipe, there is no change in that case. Whereas if you are not making any groove and straight edges you are making the weld, that is called fillet weld. So you can see over here the fillet welds, the fillet weld on a horizontal plane, okay, again on a horizontal plane, okay, vertical plane, okay, or in the case of again of a, in the case of a vertical plate, okay, of or overhead condition, overhead position, you can see. So this is a flat position, this is a horizontal position, this is a vertical position, and this is the overhead position. So you will have 1F, 2F, 3F and 4F. Same way, if you are making a groove, any shape of groove, we'll come to that later. Okay, we call it as flat position as 1G, horizontal position as 2G, okay, and vertical position of plate as 3G and pipe as 5G, overhead position of a plate as 4G and inclined position of a pipe at 6G position. So these are the types of weld positions. Normally a welder will perform the welding operations. So what are the welds a welder can perform? So the welder can perform a surface weld, he can perform a fillet weld, he can perform a groove weld, he can perform a plug weld, he can perform a slot weld, he can perform a seam weld, and finally flange weld. We will see what are these all welds are. So in the case of a surface weld on a top of a plate, you can see over here, this is one plate, this is another plate. On the top of the plate, the welder is being performing a weld. So such weld are called as surface weld. And normally it need not to be of two plate. Sometimes in the first pass of every weld, welder will perform the weld on a flat plate, okay, on a flat plate to ensure that all the set weld parameters are correct in nature. So normally the first trial of every welding, we call it as bead on plate welding. It means that the welder is performing a testing of the set parameters on a used plate to ensure that the set parameters, the robotic, if it is a robotic welding, robotic arm movements, all are correct in nature. So the first test weld normally a welder will perform, that is will be a surface weld, and that is called as bead on plate weld. That is, I cannot say that all the surface welds are not trials. Sometimes if I am joining two plates by depositing over a groove on the top of its surface, we call it as the surface welds. Okay, that is the first one. And you can see the parts. This is the welding A and B, that is together. This indicates your welding electrode. Whereas electrode which is shown over here have two constituents. The first one is electrode wire and the next is called electrode flex. So you can see the center part of your electrode, that is called as electrode wire, or sometimes we call it as core wire. So the core wire is surrounded by the flex material. You can see the one which is marked as B, that is called flex. So there is a purpose of flex is there. We will come to it in the coming classes. So this class I am not going to explain it. And you can see the electrode as well as the workpiece will be connected to the terminals of electricity, and you can see the electrode is kept at certain distance apart, and you can see the path becomes ionized and the flow of arc will establish. So the part number C, that is called as the arc. Okay, so the purpose of the flex is normally to protect this arc from the atmospheric contaminants. The main purpose of the flex is to ensure that no atmospheric contaminants will get deposited or will get added into this part number D, normally known as molten weld puddle. So you are ensuring that the flex will protect your arc from the contaminants to get added into it. Then once the weld is performed, the top layer of the weld we called it as bead, and any impurities which is present over here or in the atmosphere, that normally will be float on the surface of the bead, we call it as slag. So hope you remember that by using a chipping hammer you have removed the slag which is deposited on the top of the weld. So we can see that the surface welds are the weld where the material has been applied to and or blended with the surface of the workpiece. So the purpose of the flex here I told you to prevent the oxidation or other atmospheric gases to get entrapped into the welding. Okay, and that is only one option of the flex. There are other uses are also there that we will discuss in detail when we are discussing about the welding electrodes. And in all the welds, the shielding is not done with the help of flex. In certain welding process, it is done with the help of gases also. So the next type of the weld, that is called as groove weld. So the nomenclature of a groove weld is shown over here. So the top portion of the weld, that is called as the top portion of the weld which is projecting out of your plate, okay, that is called as toe of the weld. So it is marked from one side and from the other side is also marked the toe of the weld. So from this point to this point, whatever the weld groove, the width is, so that is marked as B here as width of your weld. Basically you can see over here, this is the actual shape of both the plates where you have gone for the groove welding, and based on the shape of this groove you can make V shape, U shape, J shape, etc. Sometimes it can be single V or double V are also possible, single U or double U are possible. So depends on the thickness of the plate, the welder needs to select if what type of a groove joint which he want to make. So the major parts is toe, I shown you, these are the toes of the weld. So this is the bead width, okay, this is called as a weld bead, so it's called as a bead width. C is the face reinforcement, this is the entire area where A to D and up to B, that is called as the face reinforcement. Joint preparation I already told you. F is the joint gap. You can see there is a gap is there between both the plates, okay, that is called as joint gap, or this part of the weld is called as root. So normally that gap is called as root gap. So you have to maintain sufficient root gap, then only the bottom penetration will takes place. So this is called root reinforcement, okay, the root reinforcement or the penetration of the weld towards the bottom side will occur only when you provide a sufficient root gap over here. If the gap is very less, then the root penetration will be minimum. If you keep excess root gap over here, what happens is that then no penetration, then even the burn through or some other defects will occur. So you have to keep the weld on the proper positions. So proper gap you have to provide, then only a good penetration will takes place over here. So normally in the case of weld joints, okay, the weld joints, the butt welding, almost all butt welding will be going with the groove welding operation, and depends on your plate thickness, you have to select what groove you have to make, that whether it is a V or U or J, etc. So you can see over here, these are some of the grooves. That the symbol or the base one is called square. So square grooves, normally when you will be going that, if the plate is of a 4 mm thick, okay, less than 4 mm thick, you don't need to make any edge preparation. You can go for square joints. You can see some information is given over here. Okay. So you will go for square joints, and hope when you did your welding trials in the lab, you have not made any edge preparation. You have directly gone for square joints, square butt joints, because the plate whatever we have given you was of a thickness of 4 mm or lesser. So you have gone only for square. So if the plate is still thicker, you can see up to 0.48 to 0.95 centimeter, you can go for single bevel joints. Then if this plate is still higher than 0.95, you have to go for double bevel joints. So single bevel, same way you will have single J. Okay, you can see 1.3 to 1.9. You will have double J, 1 point greater than 1.9. You will have single V is up to 1.9 centimeter, double V more than 1.9 centimeter, double U it is up to 1.9 centimeter. Okay, whatever the groove you are making, you have to melt and deposit the molten metal into all of these areas. Then double V is the double U is shown. You have flange welding, you will have T welding, you will have flare weldings are also possible in the case of welding. So these are the common grooves. Okay, up to this are the common grooves that you will be performing on the welding. Okay, performing on the butt welding, and the selection is purely based on the thickness of the sheet metal. So if the thickness is very less, you can go for square. If the thickness is higher, then you have to go for double V or double J or double U joints. And you can see the other types of welds. After surface weld we have seen, we have discussed the groove weld, we have discussed the types of grooves also. Then we will have the fillet weld. So fillet weld, no grooves will be performing. So this is how your weld area will looks like, or the weld bead will looks like. This is plate number 1, this is plate number 2. Here also this is plate number 1, this is plate number 2. So without any grooves on a L shape or a T or an L shape, normally when you are welding it, we call it as fillet weld. Okay, and sometimes if you want more, and if you are making it, you can see all the penetration is only up to here. If you want a more penetration of the weld to take place, again you need to cut the grooves over here, so that the entire area, the entire structure, you will get penetration. So how, or based on your loading applications, you have to choose those criteria. So it is used to fill the plates created by corner, lap and T joints. It is most common weld in arc and gas welding. It can be single or double, and can be continuous or intermittent. The next type of a weld, we call it as plug welding. So in the plug welding, what we are doing is that this is a plate on a lap configuration where I have drilled a through hole between my two plates which I kept in the lab configuration, one here and another here. Now the one hole complete cavity I am filling with the molten metal, that is called as the plug welding operation. So it is used to attach one or more flat plates. So filler material is filled in one or more holes or slots in the top part. Okay, the same filler material is used to fuse the two parts. So in a lab configuration, if lesser force is required, you can go for these arrangements. If this is supposed to be a lap welding, you can perform the welding either here or on both the sides, depends on your loading conditions. The next type of weld, that is called sport weld. Okay, so you can see these are called sport weld, and this is not known as weld bead, whereas in all other cases we call it as weld bead. These are called as weld nuggets. Okay, so weld nuggets. So sport weld, you will not make any holes as you have seen in the previous case. Without any holes, you will be applying pressure from both the areas, and you are ensuring that the metal will fuse and will get a joint over here. Normally in the case of fuse welding, this falls under to the category of solid state welding. That is, here no liquid, the metal is not converted into the liquid state. In the solid state itself, the welding is taking place, and these are called as weld nuggets. If you see your automobile car, plenty of spot welding will be there in and around your automobile car. Okay, all the robots, all the automated robots which you might have seen in various welding videos, they will be actually performing this spot welding operation on your automobile chassis and body fittings. The next one, we call it as seam welding. This is also a type of welding which falls under to the category of resistance welding, where you can see on a through area the entire structure is being welded off. This is called as the seam welding. Normally your two-wheeler fuel tanks are being welded by using this seam welding process. Okay, so rather than making in spots, here it is a continuously weld, no grooves are made, no fit-ups are being done. With the help of the applied pressure, the material is bonding in the solid state itself. So that is called as the seam welding. So spot welding, seam welding, flange welding, etc., they all falls into the category, normally under the category of resistance welding process. Okay, so we have seen so far the types of joints, we have seen types of weld process, we have seen types of weld symbols, we have seen various groove configurations, we have seen. So these all informations normally will not be printed out on any drawings. Instead of that, if it is a welding, all the welding information what we have seen so far, okay, that will be comprised in a fashion like this. Okay, which will have all the information what is required. Okay, whether it is what is the length of the weld, groove angle, pitch, where the weld has to be done, okay, either to done in the arrow side or on the opposite side, and what weld you want to perform. That is, if I can join it like this also. Okay, instead of drawing it like this, I can join it like this. If I draw it like this, if it falls on the arrow side, these all dimensions I have to return here. Okay, and if I am joining it like this, it means that it is falling on the other side, I have to perform the weld. So all the informations I will be writing here. So what is the process, what weld you are doing, so you can see the weld symbols. So if it is a spot or projection weld, how many number of weld, whether you have to perform all around your component. So this circle indicates that it is an all around weld you have to perform. So this is the way normally with these informations, a arrow and indicating a shape like this, you have to understand that there is a welding has to be done on that specific component, and what all the dimensions which is required to be there, that will be comprising in this. This is called as the weld symbol. And there is a standardized weld symbol is there, which has been which normally all the industries will follow is AWS standard, American Welding Society. AWS is American Welding Society. So they have a standardized weld symbol is available that normally all the industries will follow. Okay, so what all things it will indicate? It is a weld symbol, graphical symbol that indicates a weld required, welding symbol. So following 8 elements will be the reference line, it is required. Okay, so reference line is required. Then arrow, so this is the arrow is required. Okay, arrow connecting reference line, so this is the reference line, this is the arrow. Then basic weld symbol, whether it is a groove weld, whether it is a fillet weld, whether it is a flare weld, whether it is a spot weld, etc. Then if it is a groove weld, you have to see that what is the depth of the groove, what is the groove what is the root opening, okay, what is the groove angle is. These all informations you have to enter either on this side or on this side based on where actually the arrow is pointing. Then you will have supplementary symbols like the finish after welding, what type of finishing process it has to achieve. And you will require a tail, so this is the tail part. So here you will have some numbers to indicate to which part family it belongs to, or specification of certain other processes like current, voltage, etc. and other specifications also you need to mark on this. So normally in the case of a welding, so far whatever we have seen will be represented over here. Okay, so whatever we have seen so far will be summarized over here, that is called as the weld symbol. So this will contains all the necessary information, and an engineer's role is to understand what is mentioned over here, and accordingly the process sequence an engineer has to develop and he has to follow it. So for example, the weld symbols I told you, you can see if it is a fillet weld, it will be marked with a triangle. If it is a square butt, it will be marked with 2 lines. A single V, it will mark like this. You will have a flat, convex contour, concave contour, or supplementary finishing like G indicates a grinding finish is required. This is for a double V joint. This is for a single U joint. This is how a single bevel butt joint will looks like. If you require a machining finish, it will mark an auxiliary letter M. If it is a chipping finish, it will mark with C. So you can see over here, this is a little more elaborative information is there. If a circle like this is there, the entire area wherever it is pointing out, you need to perform the weld. So weld length, so L1 is weld length to L2, distance between center for stitched weld. D is the weld depth, so what depth you have to perform. Here weld geometry, the shape of the weld, okay, the shape of your weld, that you have to mark it over here. So either you will mark it here or you will mark it here. That is, if I want to perform the weld in the direction like this or in the direction like where the arrow is pointing, then I will enter the details in the arrow side. If I want to perform the weld in the opposite side where the arrow is pointing, I will enter the data only over here, which indicates that it is the far side details. Okay, so these all informations you have to extract from the drawings, so that you will be able to produce a good well, a good defective, a good well without any defects. See, for example, you can see this is a weld cross section. I hope you can understand that the type of the weld is, the type of the weld here shown here is the fillet weld. Okay, the weld width and depth is shown here as 5 by 16. So now you can see over here, this is my shape. So the corresponding weld symbol will be like this. So previously I have shown you that for a fillet weld it will be marked as a triangle. So it is shown as a triangle, and the weld where you are pointing the arrow, we are pointing the arrow, you can see we are pointing it on the side where the weld has to be done. So what we are doing is that we have to fill the information in the arrow side. So arrow side is what? Arrow side is the bottom side. So in the bottom side we are entering the dimensions of the fillet weld. You can see over here. Okay. Now in the second case, you can see over here I am performing 2 fillet welds on both the sides, where the dimensions also remains the same. So I am drawing a symbol like that, and I am marking it in 2 triangles like this and writing the dimensions over here, indicating that arrow side as well as the farther side also I need to perform the welding. And here, as I shown over here, if this need not to be drawn over here, I can point the arrow over here, draw it like this, and I can mark the reference like this. If that is the case, instead of drawing the triangle in the bottom, here I will mark the triangle in the top side. Indicates that the weld has to be performed in the farther or on the opposite side. Now I hope you will get a clear idea what you meant by the term called as arrow side and what you meant by the term called as further side. So this is another example where this is the part which I need to weld, and the entire area I need to weld. So this is one plate. Over the plate I have a projection like this. I had another projection that is also joined. So the entire bottom area I need to weld. So that is called as all around weld. So all around fillet weld. So I have drawn the fillet weld dimension. The weld dimension I can enter here, and I put a round over the joining area of your arrow and reference line, indicating that this is a all around weld has to be performed. So this is my the top view of the pictorial drawing. This is how a weld symbol will looks like. Okay. So you have to, so if a drawing like this is given, you should be in a position to draw like this, or if a position with dimension is given like this, you should be in a position to draw, to convert it into symbols. So this is called as weld all around symbol. Now if we change from fillet weld to groove weld, you can see over here. Okay, so the groove angle is 60 degree. The depth of your bevel is 3 by 8 inches. Okay, and finally weld dimension, that is including your root reinforcement etc., can go up to half inches. If that is the case, and you can see over here, this is my root opening where there is no root gap is provided. It is a zero root gap. Okay, zero root gap. So root opening is 0. So these all informations are there in the drawing. So these all informations should be there in my weld symbol also. So you can see over here. So this is my root opening is marked as 0. This is called as the groove angle. So groove angle is 60 degree. half of the groove angle we call it as a bevel angle. Then you can see over here the depth of the bevel is marked and the groove weld size is also marked over here. So if you got a dimension like this, you should be in a position to interpret or draw a corresponding figure like this. So this is called, this is what is normally called as the weld symbols or weld drawings. So these are some auxiliary options which is available with respect to your finishing condition. So this is a flat one, you can go for a contour without finishing. Okay, so concave shapes or convex shapes. Okay, now if you want to make it like this, C, U, M or G. Okay, this is with finishing. So C indicates chipping, M is machining, G is grinding, U is unspecified. So depends on the whatever the information it is given to you, you have to complete the welding operation. So either from a pictorial drawing you have to convert that into a weld drawing, or for a given weld drawing you should be in a position to represent that in a pictorial drawing. So some of the weld symbols quickly we will go through it. So square groove we have already discussed. So normally square groove, the root opening or the root gap will be 0. So this is how bevel groove will looks like, and the corresponding weld symbol is shown over here. This is how a V groove will looks like, so it is shown over here. And this you are doing a backing plate and you are performing the weld. So in certain welds you will be providing the backing plates. So that's a way, this is how the weld symbol in that case will looks like. And for corner joints, this is bevel groove, this is J groove, and this is square groove. Similarly, for fillet joints with grooves, you can see this is J, this is called flare bevel, and this is called bevel groove. So it depends on your application, depends on your loading condition. If you want to get more strength for a fillet joints, then you have to go for the grooves. Don't think that if all the fillet joints you will be performing it as that 90-degree mode. You can go for grooves, and the selection of groove will be based on what strength you are required on the welding. Okay, so this is one important part of the welding, where we have seen the types of joints, we have seen the types of welding process, the symbol types of joint designs. Okay, the symbol, how to convert a pictorial drawing into a weld symbol, and how from a weld symbol back into a pictorial drawing. Now we will come into some terminologies or some electric terms which comes normally in the case of welding. So as you know that in the case of welding, so electricity is required. So electricity is the flow of electrons through a conductor. Electron is the negatively charged part of an atom. I am not going to anything to define further on these things. So polarity, so the direction of the flow of electrons. So why this is important in the case of welding? So normally in the case of welding, those three parameters are important. One is voltage, next is current, and the third is polarity. So voltage is nothing but the electrical potential or pressure that causes the current to flow. Okay, actual voltage for a welding current is 18 to 36 volt. So normal voltage you will set in a welding machine will be 18 to 36 volts. Current is the movement of the charged particles in a specific direction. So when the charged particles are moving in the specific direction, the wire is heated, the heat is generated, okay, by the resistance. Okay, greater the flow of current, greater the resistance. As a result, more amount of heat will be generated. As a result, the material will get melted and deposited into the joint. So depends on what type of a joint or what depth you require to get a joint, there the polarity will have an influence. I'll come into the next slide. So arc electricity is nothing but jumping from an air gap between electrode and the base metal. Normally arc temperature is around 6000 degree Fahrenheit to 10,000 degree Fahrenheit. So you can see in the case of an alternating current, so alternating current, it's a pulsating current. So one half of the current it will be positive and another half it will be negative in nature. So this is the one cycle, as you know, and the blue color indicates the movement of your voltage and the yellow indicates the movement of your current in the case of welding. So you can see over here exactly at this is exactly at 1/120 the voltage is crossing exactly and connecting into the cycles correctly. But you can see in the case of current there is a phase lag is happening in the case of current. So I am not going to its details, not going to its electrical details, since our focus is on manufacturing process. Okay. So so AC current, as I told you, in one half it is positive and another half it is negative. So if I don't want that, I can go for DC. So in DC mode, you know that only either bottom half or either the bottom half or the top half will remains over there. Okay, based on that information, we will have two modes of supplies will be available. One, you can see over here, DC arc welding machine. You will have positive and negative. Negative terminal is connected to your electrode and positive is connected to your workbench. So this is called as direct current electrode negative, DCEN. There is the condition of polarity comes into the picture, and the effect of polarity I will show you in the next slide. So this is called as direct current. Okay, direct current electrode negative. Okay, electrode is connected to negative terminal, so it's called DCEN, or it is called as straight polarity or electrode negative. So same, I can reverse it, that is the change of polarity in DC current. If I change it, instead of straight polarity, the terminology will be reverse polarity, where the electrode is connected to the positive terminal. So when I change the polarity, there is an effect in the weld also will be happening. So you can see over here, I shown you based on the polarity we can have DC negative, DC positive or AC. So this negative or positive indicates that electrode is negative, electrode is positive, and this is the case of AC. So AC I shown you, one half it is positive and next half is negative. So you can see the flow of ions and flow of electrons will be taking place in both the direction, and as a result the weld bead whatever you are obtaining will be in the shape like this. Whereas in the case of DC negative, you can see the flow of electrons will be always from negative terminal to positive terminal, and the flow of ions will be from positive to negative. So here what happens is that, you know that as it is being done, the more amount of heat now is accumulated on the top or on the top of your electrode. More amount of heating is taking place. As a result, your size of your droplet will be larger, and as a result you can see that a wider bead weld profile you will be obtaining. Okay, that is, in this case the penetration is lesser but the width of your bead is higher. That is the case of DC negative. Whereas in the case of DC positive, you can see the movement of again the electrons which is marked over here from negative to positive, and ions are moving from positive to negative. Here what happens is that as a result of this ion movements, more amount of heat will be taken or happening in the case of plate than that of your electrode tip. As a result, the resultant weld bead will have a deeper penetration than compared to the DC negative condition. Here it is of deeper penetration. Here the bead width is higher, penetration is lesser, whereas AC will fit in between your straight polarity and your reverse polarity condition. So polarity is important because it has a direct relationship with the amount of heat generated within the base metal. Polarity does not affect as AC welding situation. I had shown with the previous figure also. One half is positive, another half is negative. So there is no permanent heat accumulating is taking place. One half your plate is getting more amount of heat. Next cycle your electrode will be getting more amount of heat. So it will be continuously, it will be changing as and when the cycles are changing. So you can see DCRP will generate more heat within the base metal. Okay, reverse polarity, DC reverse polarity will generate more heat within the base metal. Okay, so reverse polarity is used for making some welds in the vertical and horizontal positions. One way to know if you have the right polarity setting is the sharp crackling sound of the arc. Only an experienced welder can able to distinguish these sound effects. So an incorrect polarity setting will cause the arc to give off a hissing sound and will make it difficult to control the weld bead. So direct current straight polarity will concentrate more heat through the electrode and a smaller area within the base metal. So as a result, you can see this will be the net effect in the welding. So variation in the current, variation in the voltage, variation in the polarity, okay, will have a good or will have an adverse effect on the welding if you have not chosen them properly. So the next is how to generate this electric power. So the basic and the oldest one, that is called as the welding transformer. So transformer produces AC current. It is least expensive to purchase. It is the lightest and the smallest one. So current may be changed by plugging leads into socket or by rotating a hand wheel. Hope you, when you did the experiment in the lab, okay, on the top of you did it with the help of a welding transformer in the welding lab. The current was set with the help of a rotating hand wheel on the top of the machine. No moving parts. So it is simple. So a simple figure it is shown over here, AC welding transformer. Okay, so if it is a transformer, you have to understand that it is a AC power source, and in almost all the welding conditions you can get a single phase electric supply or a 3-phase electric supply, that is 220 volts or 440 volts. So this what the purpose of the transformer, it is to step down the voltage from 220 or 440 volts in the range of 16 to 36 volt, and the current will be enhanced in the order of 100 to 300 or 400 amps. Okay, so all welding transformers are basically step down transformers. So in all the welding process, voltage will be lower and current will be higher. As we have seen the condition with respect to the resistance, the Ohm's law is applied over here. So you can get the basic information from those laws. The next or the modified one, that is called as rectifier. So rectifiers normally will generate DC current. So rectifiers are also called as inverter. So AC will be converted into DC, that is why it is called as the inverter. So rectifier circuit will be there. So normally all the DC power sources are of rectifier types. So basically a transformer containing an electrical device which changes AC into DC current, that is called rectifier. They produce both AC and DC currents with the ability to produce straight or reverse polarity. So DC, when I change the polarity, you can see I'll get straight or reverse polarity. So they are very efficient, basically quiet operation, high and low range settings are possible, not very mobile, so few moving parts. Okay, so a typical figure is also shown over there, and this is a typical current voltage characteristics of a rectifier circuit. Okay, at the beginning of the well it will be, okay, you can see 36 volt, and the end slowly it is falls back into 0. Based on the shape of the curve, this is called as drooping characteristics of the rectifier circuit type power sources. Okay, this is called drooping characteristics. Now there is a next variety of power sources is available. Okay, that is called constant voltage or constant current power sources. Okay, so initially it was transformer. From transformer it has moved to the rectifiers. From rectifiers they have moved to the thyristor controlled power sources or electronic power sources, and and now all the modern power source manufacturers, based on specific application type, they have their own power sources. So Lincoln Arc is one of the major power source manufacturer. You will have ESAB as another one. Okay, you will have Miller, you will have Kemby, okay, you will have Fronius. So these are the major power source manufacturers which is producing power sources and welding consumables in the market. So CC or CV, so CC is constant current and CV is constant voltage power source. A typical constant voltage power source is shown over here. You can see over here, these are the arc lines. Okay, these are the 3 arc lines based on 3 different current and voltages drawn. When you can see, this is a when you take a similar point in all the 3 lines based on the drooping characteristics, you can see over here the change in current. Okay, the change in current between your blue and red line, when you compare the same between the blue and red line, the change in voltage is very minimum. Okay, so when the change in voltage is very minimum than compared to change in the current, that is called as constant voltage power source or CV power source. Most of your MIG welding for your metal inert gas welding process, you will be going for CV power source. Same way you can see the third point, the third arc characteristics line. Again on this you can see over here, between your red and blue or between your blue and green, if you see, the change in the current is larger but change in the voltage is negligible. The same way, if you are able to plot in the reverse manner, where the change in current is lesser than compared to change in the voltage, that is called constant current power source. Anyhow, this is to more deep, I am not going. So this is the difference between a CC and CV power source. Yeah, so we can see this is a constant potential MIG power source. So maintains approximately the same voltage regardless of the amount of current drawn. Unlike a constant current machine, stick welding, where there is a steep slope or drop off amps. The first one, the first figure where we have shown you the steep down, that normally fits into the category of the constant current one, where the current change will be negligible but voltage change will be larger. So if the wire or electrode is fed at a faster rate, the current increases. If it is slowed down, it decreases. So easier to train an operator. Okay, achieves good well, not very mobile, lesser splatter, lesser spatter, continuous wells are possible, and the supply of shielding gas is you can able to provide. So this part we will discuss it later. Less moving parts. Okay, so a constant voltage power source, and you can see that it is marked here as a GMAW process. It is gas metal arc welding process. Under GMAW process, there are two processes there. One is called MIG, metal inert gas welding process, or metal active gas welding process. When I take the GMAW process, I'll give more details over there. So the next type of the welding machine, that is called as motor generated. So welder powered a gasoline motor, so provide DC straight polarity or DC reverse polarity or AC. It is an expensive power source, many moving parts are there, the sound is also high, very mobile, alternative power source. You can see this is how a welding a motor generator. You have an engine is there, engine is the prime mover. Okay, the engine will be coupled to a generator which will generate your current. You can keep a rectifier circuit to get a DC SP or DC RP in that case. So these are the common power sources which you will use in the welding. And there is another parameter also you have to take care when you want to choose a power source, that is called duty cycle. So duty cycle is a percentage of a 10-minute period that a welder can operate at a given current setting. That is, if it is given as 60% as the duty cycle, it means that out of a 10 minute, 6 minutes, okay, 6 minutes the welder can able to perform the weld easily. Rest 4 minutes it will be idle. Okay, rest 4 minutes it will be idle. So these are the basics of the weld joints. So we have seen the joint configurations, the weld symbols we have discussed, and power source we have discussed. We have seen the settings in the power source also we have discussed. How to select a power source, that also we have discussed. With this, I will wind up the lecture number 22. We will discuss more in details, or we will clear your doubts in the next class. Thank you.